So welcome again to East Academia. So my name is Brian Modeno, and today we are going to talk about the El Hospital rule of evaluating limits. So like we said in the previous video, that the El Hospital rule, just like the direct substitution method, you are going to use it to evaluate limits in situations whereby direct substitution fails. Okay. So the El Hospital rule is based on differentiation. So it's based on differentiation, which is this differentiation is the thing that we are doing exactly for this calculus 1. So you have to know differentiation. So first of all, before even I talk about the El Hospital rule, I would want to talk about differentiation, and especially the type of the technique that I'm going to talk here. There are various techniques of differentiation, but the one that I'm going to talk here specifically is the one is known as the power rule. So this is just a shorthand, but it means power. So you'll find me writing mostly this way. So it is the power rule. Yeah, it's the power rule. I don't know how to say PR, because mostly PR, there's another technique known as product rule, which we are going to talk about, and then we have another technique known as quotient rule, which are the ones that are usually abbreviated with PR or QR. That way. So power rule, let me just say that's power rule differentiation. So whatever I'm going to tell you about power rule in differentiation is that power rule, it's nothing but you are like, for example, it's good for me to explain an example. So for example, if you have 4x cubed plus 58x squared plus 3x plus 4, and I'm told to differentiate this using power rule. So power rule, what it does, and it is the most basic, or rather the simplest form of differentiation, is that you look at the power of x. Okay, so this is x raised to power 3, this is x raised to power 2, and then for this one, which is not written anything, it's nothing but x raised to power 1, and then for the constant, it's x raised to power 0. Okay, because any number raised to power 0 is 1, and then 4 times 1 will just remain with 4. Okay, so even if you take a million or whatever number, when you raise it to power 0, it's 1. If you don't trust me, I think I can have it shown to you here with a calculator. So for example, you take a number, let me just guess a big number, 8695438. Then this number, I raise it to the power of, let me just delete that. I raise it to the power of 0, so it gives me 1. And 1 multiplied by that number, you just get the same number, isn't it? So in essence, here we've not changed the question. We've not changed the meaning of the question. So in power rule, what this happens, that if you write this equation this way, then now you can easily evaluate using power rule. So in power rule, what you do, the power of this section, like the power of x in this first term, so you go every term that is separated by a plus. This power, you bring it down and multiply with the coefficient. Okay, so you bring it down and multiply the coefficient, and then you raise that x into a power, but that power now you subtract 1. Okay, this one is easily illustratable by doing it like an example. So if this is if this is f of x, so I'm just going to use then f prime of x, which I said is the first derivative, will be, now, so here the power is 3, so I'll take 3, multiply by 4, so I'll drop this 3, so you drop the power and then you subtract 1 to get the new power. So the thing is that, so here I will have 4 as the previous coefficient, and then I drop this 3 as the power of x, and then now the x, instead of x raised to power 3, now it will be 3 minus 1, you subtract that power, so it will be x squared, and then plus the next one. Now this, since it's power 2, so it will be 58 times 2, and then x 2 minus 1 will be 1. Okay, and so there's no need of even writing something raised to power 1. There's no need of you writing it's raised to power 1, so I can decide to wrap that so that my work becomes neat. Sorry about that. And then the next one is 3. We have, so I'll have here plus. The next one is 3, the power is 1, so 3 times 1 will be 3. And then 1 minus 1, the power will be x raised to power 0. But we said any number raised to power 0 will be that number. So there's no need of you writing x to power 0 because this will be 1. Will be 1, I mean. Any number raised to power 0, it's 1. And 1 times that number, it's just that number. And then the next one is 4. But now, since we said there's an x raised to power 0 here, so now you are going to drop this 0 multiplied with 4. 0 times 0 is 0 times 4 is 0, isn't it? And then so we'll have 0, and then we'll have 4 raised to power x, but now minus 0. But any number multiplied by a 0 is a 0. So the rule is that when you differentiate a constant, you get 0. Okay, so anytime you differentiate a constant, the answer is a 0. So this part we can do away with this part. So now we can come here and clean this up and see how it is. So this one is going to be 4 times 3 is 12 x squared plus 58 times 2. That one we're going to get it's 116. So 58 times 2, I think it's 116. So we're going to get here 116x plus 3. So this is the first derivative. Okay, and then if we take the second derivative, now f double prime of x means you are differentiating this first derivative, then differentiating it again with respect to x again. So that means this one now will be, I will drop this one here, so it will be this one, it will be 24, and then the power will be 1, so it will be 24x plus 116, then this will remain 116, and then this is a constant, so it will be 0. Then this one I can even go to the third one, third derivative, and the answer will be 24. And then I can go to the fourth one, and since it's a constant, the fourth one will be a 0. So that's power rule differentiation. Let's have another example. Before I give you an exercise, the normal exercise that you usually do. So here, today let's have y is equals to 2x squared plus 7x plus 1. So the first one, when you have y prime, will be based on power rule is that you take 2 times 2, then minus 1, that power, so you're going to get 4x, and then this will be since this was raised to power 1, 1 times 7 is 7, and then x power 0 is just 1, and then this is a constant, so it will be 0. And then y double prime will be 4, and then y triple prime will be 0, and then y the fourth one will be 0, and so forth. So let's have another one. So power rule differentiation, basically it's the most simple way of differentiating. So let's have f of y is equal to 10y squared plus 8y plus let me just write something here, plus 8 plus 15 y cubed minus 100. So the first one will be, the first derivative will be f prime of y. So this will be 20y plus 8 plus 45y squared. Then this minus 100 will just be a 0. So now I'm going to give you a question here to see if I can understand, if you've understood power rule differentiation. So the question is f of x is equals to 10x raised to power 5 plus 3x minus 15x raised to power 4 minus 32 plus 6x squared. So what is the solution to this question? So take 5 minutes and then get the solution before we do it together. Okay, so the solution here based on power rule will be f prime of x. Make sure that we denote that this is the first derivative, okay? If you don't denote, then I don't think we will be getting that answer, because suppose if you write for me that the answer now it's you don't put this apostrophe, you see that then that will be a wrong annotation. So the correct annotation, and that's why I started this series of videos with telling you that the first derivative is written that way. So this will be 50x raised to power 4 plus 3 minus 60x raised to power 3. Okay, then minus 32, it's a constant, so it will disappear because it's a 0. And then we will have this one, we're going to have plus 12 x. Yeah, so the second example that I'm going to give you, is find f raised to power 4 of the following equation. So the question that I'm going to write for you, I won't have a very difficult example, so I'm just going to give you a very simple one. So I'm going to have f of u is equals to u raised to power 3 plus 5u squared plus minus 8u minus 47u raised to power 8. So try to solve this one, and then remember this is minus, and then we are going to solve it together. So I'm going to give you 5 seconds for you to solve that one. Okay, so the solution, you are told to find the fourth derivative. So we'll begin, you can't get the fourth derivative until you go the first derivative, second, third, that way. So this will be f prime of u, so it will be 3 based on power rule u squared plus, here we'll have now 10u, and then here will be minus 8, and then here will be minus 47 times 8. So here you can employ a calculator. 376, so get 376 u raised to power 7. So that's the first derivative. And then now we go to the second derivative. Second derivative of this will be, you differentiate now this one, you differentiate the first solution to get the second one. So it will be 6u plus 10. 10 minus 8 is a constant, so it will disappear. So we'll remain with minus. So we'll have 376 times 7. We're going to get it 2632 u raised to power 6. And then you go to the third derivative. So this will be 6 plus this constant won't be there because a constant will disappear. So it will remain with minus here. So this one now, that minus sign will affect this sign. So now we'll have, or you can just put it and then see how it be. So we have minus. So we drop. So we multiply this by 6. So we're going to get 15,792. So 15,792 u raised to power 5. So the solution here will be 6 minus 15,792 u raised to power 5. Okay. Then the fourth derivative, so f raised to power 4 of u will be, this constant term will disappear and then will remain in the subtraction sign. So it will be minus. So you drop this power multiply by this one, so it will be this answer times 5 now, which is 78,960. And that is the answer for the fourth derivative for that question. So I hope you got it. And for these questions, the way I usually mark, I usually go in an orderly fashion. Like I see how you are getting, I'm just going to give one mark for the first derivative, a second mark for the second derivative, a third mark for the right third derivative, and then the last final mark will be here for the, so total marks maybe here you can get is 4 marks. But you know, for one bad thing is that when you fail the first one, you're not likely to even get these other ones. So that's the problem, and that's where so many students have an issue with. So it's good for you to be very careful in whatever you are doing, and then be very careful in whatever you are doing. And then we have programs that maybe can do for us this differentiation and all that. And sometimes I can even ask you to find the 10th derivative. So it's not an issue. It's for you to just understand. The good thing is that have you understood what differentiation is? So basically that's the differentiation. And then the next video will talk about the L'Hopital rule. And then but the L'Hopital rule is just based on exactly what we have done here now. And the solutions are obtainable through this technique. And thank you. Have a nice time. Thank you.